Hello, and welcome to the next webinar in my series on C++ Standard Template Library by Example. Today, we're going to continue our coverage of function adapters, picking up where we left off yesterday, where we covered binders. Now that we've covered binders, we're going to talk about another example of a function adapter, which is called a negator. And we'll see that there's a number of different negators. In addition to talking about the negators and showing some examples, we'll also have a chance to revisit some of the binder functors and take a look at how they've evolved over time with different versions of the C++ standard. So without any further ado, let me go ahead and share my screen, and you can see where you can find the code. You can find the code in my GitHub repository in the C++ STL S-09 folder, and the code we'll look at today is in the 9.3 subfolder. So let's go ahead and take a look at the code. We're going to start off by quickly defining what a negator adapter is. And a negator adapter is basically a functor that can be used to store the opposite result of another functor that it encapsulates. And you can see that there's several different negators that have been defined over time. Some of them came around in the early 2000 time frame, including not1 and not2. And not1 basically is expected to work on a unary functor, a unary operation, whereas not2 works on a binary functor or a binary operation. And then there's a newer functor that's come in more recent versions of C++ called not function or not fn. I'm going to call that not function just to make it easier to pronounce. And not function is a very special template that can work with either unary or binary functors, and you don't actually have to distinguish it lexically by having it be called not1 or not2, which has always been a little bit confusing. To see how these different negators work, we're going to create our own template for a simple Boolean functor that'll check to see if a value it's passed is either odd or even. If you pass it an odd number, it'll return true. If you pass it an even number, it'll return false. And this template only takes one argument, so it's basically a unary function. Here you can see the definition of this generic functor is odd, which is in fact a unary function. And you can see that its function call method, which is of course what defines a functor, takes type T parameter called number, and the body of that function mods the number by 2. And if we get a remainder, that means it's odd. If we don't get a remainder, that means it's even. So of course, it's returning a Boolean value that's true or false. We're also going to have a little helper method called print results, which will show off some interesting techniques involving template parameters. And we'll use this in order to be able to print the results of our computations without having to litter our code with all those calls to copy, as we've been doing up to this point. We're going to use the isOdd template with the STL algorithms remove copy if and copy if, and the STL functor negators not1 and not function. The copy if and remove copy if algorithms all take 4 arguments. The first 2 are the input iterator, beginning and end, first and last, as always. The next parameter is an output iterator, where we're going to put the results. And then the final parameter is a predicate that we'll use to determine whether or not the elements in the range go into the results or not. In our case, we're doing it for isOdd, but of course, these functions can be used more generally for other kinds of predicates beyond isOdd. So let's take a look at the actual code. We're going to define ourselves a vector v1, vector 1, that has values 1 through 4. They don't really have to be in any particular order. And then we define ourselves an empty vector, vector 2. We're going to start by using remove copy if. And what we're going to do here at a high level is we're going to go through all the elements in vector 1 from beginning to end. And anything that is an even number is going to be omitted from the copy. Anything that is an odd number, however, will be put through and will actually end up in the results. And the results will end up being put at the end of vector 2 by using the back inserter. And we've talked about back inserter before, so I won't talk about that here. So let's talk about the actual predicate we pass in. Of course, we're going to use our isOdd functor, and we're going to negate it by using the not1 negator adapter. And what not1 does, as we'll see, if we go take a look at not1 is a little function. It's a template function, so it can do some magic type deduction here. And what it's going to do is it's going to take in the functor that it's passed, which is, of course, itself will be treated as a predicate, and it'll end up creating something called a unary negate object to hold on to that predicate. And if we go see unary negate, you can see that unary negate is going to go ahead and hold the predicate in a local field in a data member called m_pred. And of course, the key operation in all the functors is operator function call. And you can see what it's going to do here. It's going to go ahead when called, and it's going to call the underlying functor that it's stashed away in its constructor, get the result, and then it's going to turn around and negate that result. So that's basically what it does. It negates the results of calling functor, a functor that it owns or that it stores in its data member. Okay, so that's what we're going to do to negate the is_odd value. Now you might ask the question, why are we doing it in this somewhat convoluted way by doing remove copyIf and then negating? Isn't that really just doing copyIf without the negation? And the answer is, you're correct. And the reason we're doing this to start out with is that when C++ STL was first standardized, they accidentally left the copyIf algorithm out of the standard. So for the longest time, there was only remove copyIf in the standard. So a lot of people had to get used to using remove copyIf in conjunction with a negator in order to be able to get the copyIf semantics. So that's what we're doing here. We're just staying true to the origins of this. Don't worry, I'll also show you the use of copyIf here in a second as well. When we're all done, we're going to go ahead and print the results of vector 2, and we'll show how that print works in a second. The next thing we're going to do here, just for kicks, is I'm going to switch over from using a vector to using a deck as the output iterator where the results are stored, just to illustrate how you can mix and match these things very conveniently in a number of different ways. As before, we're going to use remove copyIf, but this time, instead of using the not_1 negator, which has been around since the early 2000s, we're going to switch to a newer variant called not function or not fn. So if you go look at the not function, you can see it's using much more advanced features that are more C++ 11-ish features than the sort of 2003 STL C++ features that were there with the not_1 negator. And in fact, you can see what it's doing under the hood is it's forwarding the parameters, which are passed in as R-value reference, and it's doing some other magic with various adapters and function mechanisms built into C++ and STL. And basically, it's negating things, but it's doing it in a way where it'll work both for unary and binary functors, not having to explicitly express them as not_1 or not_2. So that's really the reason why people are moving towards not function. And the other functors, in fact, the other negators, not_1 and not_2, are actually being deprecated. You can still get to them, but if you want to write future-looking code, you should get used to using not function instead of not_1 or not_2. When we're done, we're going to, of course, insert everything into our deck this time, and we're going to go ahead and print the results of the deck. And I'll show you that code in a second as well. Well, after doing that, we're going to go ahead and reset our output to be back to 0. So we're going to set its size back to 0, so the deck's back to being empty again. And this time, we're finally going to use the copyIf algorithm. And as you can see here, the copyIf algorithm is a lot more straightforward to what we're trying to do, because we're going to start from the beginning of vector 1, go to the end, just like before. We're going to back insert into deck 1, which is now empty, of course, or at least initially empty. And this time, rather than using negators and all this stuff we just looked at, we're just going to use a good old C++ Lambda function. And you can see that this Lambda function is really the same code that we had done up here in our is_odd functor, except now we're able to plop it in line by using a lambda. And you can see this is a lambda because we have the open close square brackets, and we'll talk more about how that works a little bit later. And then we're going to make this a generic lambda function by having it take in an auto keyword, which means it'll work with anything that has one parameter here, which in our case happens to be an int, but it could be a float or a double or something else. And then what we do is we take the number, we mod that by 2, and check to see whether we had a remainder. So it's basically doing the is_odd computation from before, except now we're doing it in line. So that's the third different variant. We did one variant that used not_1, we did another variant that used not function, and then we did a third variant that used a lambda function. Which one should you use? Well, of course, if you're stuck with old versions of C++ as your compiler, then you're probably going to have to use the not_1 variant. If you're using newer compilers, C++ 11, you can pick using not function, or of course you can use the lambda function style as well. I think it really comes down to how easy is it to tell at a glance what your code is doing. So when you look at this code, it's pretty clear that you're negating the results of the is_odd functor. So I think that's pretty intuitive. When you look at this code, it might not be quite as obvious, unless, of course, you have memorized how you check to see if a number is odd or not. And so it helps to put a comment, of course, which I've done, but it also may be a little bit less intuitive. So it's kind of a trade-off. The nice thing about the Lambda approach is it's directly in line, and you don't have to go searching around to see where your functors are defined. The downside is it may be longer amounts of code. And especially if you were planning to do lots of checks to see whether something was odd, you might want to actually make your own explicit functor in that case and use it as we've shown here in either the remove copy if negator form or the copy if non-negator form. Now that we've talked about these topics, let's go ahead and show how we're going to print out the results, or how we do print the results. And as I mentioned before, this is an example of a template parameter passed to a C++ function. So print results takes a type name t, which is the elements we're working on with our container, and then it also takes a template parameter itself, which is going to be used to pass sequential containers, things like vectors, decks, or lists. And as you can see here, we're going to take our sequential container that gets passed in, and then we're going to go ahead and write a little generic piece of code where we start at the beginning of the container, and we're going to go to the end. And this way we can kind of pass the whole kit and caboodle in as a const ref. And then we're going to go ahead and use the ostream iterator with parameter t, which is the type parameter that's passed to this template, in order to be able to do the iterator adapter technique we've looked at before to get the results written to the output. So that's one particular way of doing things. Obviously, we're going to see some other ones when we look at the next example, but this is a nice example of showing how you can use template parameters if you want to be able to pass over and print the entire contents of the container that you just manipulated using remove copy if or copy if. So that's the end of our first example. Now let's go ahead and take a look at the second example. And this is also quite interesting, and this will give us a chance to talk about yet other aspects of negators, and in fact, it'll give us a chance to return to our discussions of binders, and it'll give us yet another chance to talk about another way to implement the print results method. And this one, rather than taking in the whole container, is just going to take an iterator to the beginning of the range we want printed and to the end of the range we want printed, and it'll go ahead and do some really cool type deduction. And we'll take a look at that as well. So let's start off by defining an overly specific functor. I call this functor int greater than 3. And I probably would never write code like this, but I just want to be able to show how you could do this if you wanted to get really, really specific. So int greater than 3, of course, is a unary function. And kind of like the isodd function, it takes in a parameter. In this case, we've hard-coded it to int, and it's going to check to see whether the parameter x passed in is greater than 3 or not. If it is greater than 3, it'll return true. If it's not greater than 3, it'll return false. Now, you should know right off the top of the bat that this is not the best way to write functors, because there's already functors that exist in STL that can be adapted using binders to work in the way that we would use int greater than 3. But we'll talk about that in a second. Okay, so let's take a look at the example, the main program. And you can see we're going to demonstrate the use of functors being used with not 1, not 2, and the not function negators that we've talked about so far. We haven't talked about not 2 yet, but you'll see how that works. And then we're also going to take a look at the various find if and find if not STL algorithms. And of course, because it's important to know how to compare and contrast the use of functors with lambda expressions and lambda functions, we'll also take a look at that as well. So let's start out with the actual source code. We're going to define a vector that has several elements. It has the elements 4, 1, 2, 8, 5, 7. And it actually kind of matters for our example that they're in that order, as you'll see in a moment. The first thing we're going to do is we're going to use our custom functor, the int greater than 3 functor, and the not 1 negator, kind of that legacy negator, to get an iterator to the first element in our vector that has a value that's not greater than 3. And so let's go take a look at find if. We've talked about find if before, but it helps to refresh your memory. Now, find if is one of these kind of funky methods that isn't quite where you think it is. And in fact, its actual implementation, if you want to see the actual code, lurks in the alg-base.h file. And so if you take a look here, our CLion code got us to this point, and then you can see it turns around and calls underscore underscore find if. Well, it turns out you can't find that method in this file, and it turns out CLine won't take us there directly, but I found this a little bit earlier, and I brought up the code so we could take a quick look at it. So you can see here that find if takes, in this case, it's going to take a random access iterator, because of course we're working with a vector, and it takes a predicate. And then down here, you're going to see that what we're going to be able to do, whoops, I take it back. Here's the find if we're going to take a look at. This is an overloaded version that's used, or a template specialized version. Here's the one that we actually want. This is going to take an input iterator, which in this case will be a random access iterator, and a type name for the predicate. And find if takes the range from first to last, as always, and it takes the predicate. And then if you take a look down here, you can see what it does is it goes through that range, as always, iterating through it. And what it's going to do is it's going to check to see whether or not there's a match on the predicate. And if there is a match, then we're done. If there's no match, we keep going and we keep incrementing first by one. So that's basically what find if is going to be doing here. And keep that in mind, because we'll come back and talk about it a little bit more in a second. So what we're going to do is we're going to go ahead and have the predicate be not int greater than 3. And of course, that's going to return an iterator. And in this case, the first element in this vector that's not greater than 3 will be the second element in the vector. So we're going to get an iterator back to the second element. And then what we're going to do is we're going to use our print results method, this new print results method, to start at the iterator match and then go to the end. So it's going to skip over the 4 in this case and start printing at 1, and it'll print 1, 2, 8, 5, 7. Okay, so that's the first variant. Now let's come down here and take a look at what we could do if we wanted to do kind of more standard code, get rid of this crazy, overly specific custom functor. So in this case, we're going to do much the same thing with find if, except in addition to using not one, we're going to pull out our bind second method that we'd taken a look at yesterday. And this is basically a functor that knows how to adapt other functors. And in this case, it's going to adapt the greater functor, which is a predefined functor that's an STL, and it's going to bind it to 3. So what this is basically saying is, find me the first element, give me an iterator back to the first element in the vector that is not greater than 3. And now we're not having to write our own custom functor. We're using the greater functor that already exists in conjunction with the bind second binder to bind its second parameter to 3, and then we go ahead and encapsulate that inside the not one negator. So you can see how we're kind of chaining these adapters together in order to get the result that we want. Well, not surprisingly, we'll get the result that we want. We'll once again get back an iterator that starts here at 1, because that's the first element in the vector that's not greater than 3. All right, so now let's go ahead and take a look at the more modern ways of doing this. And we'll see a couple different variants. For various reasons, the binders that we talked about yesterday, bind first and bind second, have also been deprecated, much like not 1 and not 2. And that doesn't mean that they don't exist anymore. It just means that you should start thinking about alternative ways of doing things. And the technique that was introduced to do this is something that's called bind. But for various reasons, bind has fallen into ill repute. And in fact, I'm going to show you how to do it, but then I'm also going to show you that it's actually discouraged. And we'll take a look at that in a second. But first, let's talk about what bind is. And in addition to using bind, I'm also going to use the not function negator instead of using the not one negator. So this is a modern negator used with a more modern binder, if you will. And so what we're going to do here for the binder is we're going to go ahead and say, I want to bind greater. And the other cool thing I can do with this is I can use this more concise form of using a functor. You can leave out the type parameter and it can figure it out. Unfortunately, you can't do that with bind second. The compiler gets confused for various reasons. So we have to be a little bit more verbose. That's another reason why they have deprecated bind second. So here's the binder. We say, I want to make a binder that'll bind something to greater. And you can tell that this is going to be a bind second approach because we're going to leave a placeholder for the first parameter. And of course, that placeholder is going to be replaced with the elements that are in the range from beginning to end of the vector. And then the third parameter to bind is going to be the value 3. So once again, we're going to be creating a binder that will find the first element that's 3 and then we use not function to negate that. Now, I don't know about you, this actually is arguably better than bind first and bind second in some ways, but it's also kind of ugly. And in fact, you can tell that it's fell in disrepute, because if you take a look here, the IDE is telling us use a lambda function rather than using bind. We really think bind's a bad idea. So be that as it may, I'll show you the lambda function in a second, but this is the way that you could use bind. And of course, if you wanted to swap the order, you could turn this into a sort of a bind first by putting the 3 first and then the placeholder second. So that would be an easy way of getting the effective behavior of bind first. But right now we're doing bind second. All right, so here is the final way of doing things that we're going to show. And this is going to have a little fun. In addition to using the lambda function syntax as opposed to using binders and pre-existing functors, we're going to use the lambda function, and then in addition to that, we're also going to use the find if not method. And find if not, as you might imagine, basically negates, it implicitly negates the predicate. So we don't have to negate anything anymore. So let's go ahead and take a look at find if not. And I think this is another one of those methods that actually is not where you might think it is. So let's take a look at find if not. And maybe we'll get lucky, maybe we won't. So find if not is also something that's defined, and basically it's just the negation. It just negates the predicate. So it's kind of like using a negator, but it hard codes that into the actual algorithm itself. So you can see here's find if not, and if you look around, you'll find the source code for it. So if you take a look, we use find if not, and then we write a lambda function that's just going to go ahead and take in the parameter I, which we use auto for, so it's a generic lambda function, and it's going to return I greater than 3. And since we're using this with find if not, we don't have to negate it anymore, and so it's going to return the first element that's not greater than 3. Okay, so far so good, and we print those results. Now I'm just going to show you not to, and not to is basically the binary version of not. And you might wonder, when would you ever use it? And the answer was not very much. And here's one example where you could use it, although it turns out it's probably not the best way to make it be sorting. So we're going to use it for sort, where we're going to start at the beginning and the end of the vector, and we're going to sort it, and we're going to sort it in descending order by using not to on the binary functor less. So basically this is equivalent to greater. So not to less is basically greater. And just for kicks, if you don't want to use not to, you could use not function, and that would also work nicely here as well. And this is really the reason why they've gotten, they've deprecated not 1 and not 2, because not function can do the job of not 1 and not 2 without you having to lexically add 1 and 2 to the call when you invoke the negator. Okay, so that's the code. Let's go ahead and run the code, and then I'm going to show you the print results method. And you can see here what it does is it goes ahead and skips over. It finds the first element that's not less than, not greater than 3, which is of course 1, and then it prints the results out. And then the final thing we do is we go ahead and we sort it not less. So it's in descending order. The last thing I want to do is I want to show you this very interesting print results method. This is a different way of doing things, and it works nicely here because we're not trying to print the entire container. We're just trying to print it from wherever the iterator came back up to, but not including the end. So here's what we do. We're going to make this thing be parameterized by an input iterator. It's a template. It's a generic print results function, and it takes a first and a last. If first does not equal last, that means that we actually found something with our iterator. And so that what we're going to do is we're going to copy from the first input iterator up to, but not including the last element. And then we're going to go ahead and use our OStream iterator to write the results out. Well, the interesting question is here, OStream iterator wants a type. It wants int or double or float or employee record or whatever we're dealing with. So how do we actually get that? Well, what we're going to do is use a little bit of type deduction magic that's also been added more recently to C++ called Deckle Type. And Deckle Type is this cool sort of template metaprogramming type system mechanism where you give it a value, in this case, star first. So whatever type we've got here, star first is an instance of the iterator type that we've got. And Deckle Type then statically converts that into the type that star first corresponds to, which in our particular case happens to be int. So that means we're going to end up using OStream iterator less than int greater than. And so that's a way of being able to let the compiler deduce the type from the parameter that was passed in as the first parameter or the second parameter to our print results method. So this is a really cool little technique. This helps us to write more generic code without having to do all kinds of other awkward things of passing in type parameters and so on. So this makes it really clean, really concise, and we can stick to just passing in input iterator ranges, and then we can use Deckle Type to deduce the final type. Okay, so those are the things that I had wanted to cover in the session today. So at this point, we've covered binders, and you've seen kind of the old school bind first, bind second binders. You've seen the newer binder approach, which is bind, which has been a little bit itself sort of quasi-deprecated, even though it's fairly new. People typically say, stick with using Lambda functions, although quite honestly, once you get used to this somewhat strange syntax of bind, it's not too bad. And I'll actually show you in upcoming sessions how you can nest binders, which is pretty cool. And then the other thing we talked about, of course, today, our main focus was on negators, and you saw the old style negators, not one and not two, as well as the newer style negators, or the newer style negator, which is the not function or not underscore FN negator. So hopefully this was helpful to you. If you enjoy the content, please like and subscribe. And of course, also feel free to follow me on Twitter. So thanks very much, and I'll look forward to seeing you again soon.